The concept of creating a taps into a long-standing human desire to develop energy-efficient and self-sustaining power systems. Known in some circles as a free energy magnetic motor, the idea revolves around constructing a generator that can produce more energy than it consumes. While mainstream physics may challenge the feasibility of this concept, the field continues to inspire inventors and enthusiasts. This essay delves into two main categories of such devices: a generator with an integrated motor and an AC generator connected to an induction motor. Generator with integrated motor. The first category explores a device where the generator itself also functions as an induction motor, allowing it to both produce and consume electrical power. There are two key inputs to consider. Kinetic energy input. This involves applying mechanical energy, e.g., from a turbine or flywheel, to the generator. In this scenario, the generator head produces electricity but rarely integrates an induction motor. Most conventional generators in practical use fall into this category. AC/DC power source input. This scenario envisions supplying electrical energy to the induction motor within the generator. Here, the motor accelerates the generator, which, in turn, produces electricity. The exciting possibility in this configuration is that the output energy could potentially exceed the input, creating a self-sustaining loop of energy production. While such integrated devices are not commercially available, they often take the form of experimental inventions, driven by the goal of creating an over-unity device, one that outputs more energy than it consumes. These machines rely on magnetic and electrical principles to overcome energy losses, especially focusing on reducing or exploiting back electromotive force, back EMF. Basic structure and operation. The key to these devices lies in their basic structure. A DC or AC voltage pulse is applied to coils that accelerate a flywheel containing magnets. This rotating magnet generates electrical energy in the surrounding coils. Importantly, fewer coils receive the initial pulse than those generating electricity in the stator, which creates a potential for greater electrical output. To reduce the opposition from back EMF, engineers work on converting this otherwise useless force into useful energy. Back EMF is the natural resistance generated by an electric motor when current is applied. In conventional designs, it opposes motion, reducing efficiency. However, advanced techniques aim to neutralize this resistance or repurpose it to enhance the energy output, transforming a liability into a strength. One promising area of exploration is the ether field of the permanent magnet, where the interactions between magnetic fields and an invisible, energy-carrying medium, often referred to as the ether, can lead to enhanced energy output. This technique remains highly speculative but is central to many theories surrounding free energy magnetic motors. AC generator connected. The second major category of homemade generator motors involves connecting a standard AC generator to an induction motor. Unlike the integrated motor-generator combination, this setup features two separate devices working in tandem to generate and regulate power. The AC generator head produces electricity while the induction motor provides rotational energy, and they are mechanically connected, often via a belt or flywheel. The flywheel serves to maintain inertia, smoothing out fluctuations in energy demand, and making the system more efficient. Electronic components and back EMF exploitation. In this setup, electronic components such as diodes, capacitors, and resistors play a crucial role. Their purpose is to regulate the flow of electricity and manage reactive power, the portion of electrical energy that does not contribute to actual work and is usually lost as inefficiency. By optimizing the flow of reactive power and controlling back EMF, the system can produce a near-constant flow of usable energy. Reducing back EMF is once again a central goal. By carefully designing the system to minimize this counterproductive force, the generator motor can potentially produce more energy than it consumes. This is where the idea of free energy comes into play, with proponents of this design arguing that the combination of the right mechanical connections and electronic circuits can result in an over-unity system. The beauty of this approach lies in its simplicity. With the right wiring and electronic circuits, and by adding a flywheel to maintain inertia, a generator motor of this type can theoretically achieve self-sustained operation, providing free energy. Historical and modern inspirations: Tesla's method and over-unity. The notion of amplifying electrical energy is not new. Nikola Tesla, one of the greatest inventors in electrical engineering, pioneered methods to magnify power by neutralizing magnetic counterforces in electric generators. His work serves as a historical reference point for many modern-day free energy enthusiasts, who see Tesla's designs as precursors to the self-powered generator concept. Tesla's approach involved reducing the drag created by magnetic fields within generators, allowing them to operate with less resistance and, therefore, higher efficiency. While the specifics of his method remain somewhat mysterious, Modern technologies attempt to replicate his ideas using induction motors and alternators connected in unique ways. Additionally, terms like overunity free energy and zero-point energy (DPE) are often used to describe systems that generate more power than they consume. While mainstream science may reject these concepts, inventors continue to experiment with magnetic motors and self-powered generators, driven by the belief that Mother Nature harbors untapped energy sources that can be unlocked with the right technology.